students, welcome back to my YouTube channel PD Tutorial, and today in this video I am going to solve some example using Chinese remainder theorem. Okay, the first question is solve the system of linear congruences this using Chinese remainder theorem. Okay, so let's see solution. Comparing, give it equation 1, 2, 3, equation 1, 2 and 3 with the system of linear congruence x congruent a1 mod n1, x congruence a2 mod n2, x congruent a3 mod n3. So after comparing with this, we get a1 is equals to 2, a2 is equals to 3 and a3 is equals to 2. Similarly, n1 is equals to 3, n2 is equals to 5 and n3 is equals to 7. So when we find a unique solution for this given equation, okay, as we read in the Chinese remainder theorem, I have also uploaded the proof of Chinese remainder theorem. You may check the link in the description box. Okay, say x bar is the unique solution for this given system of linear congruence. Then it will be find as a1 n1 x1, a2 n2 x2, a3 n3 x3. So we have to find n1 and x1. Okay, so let's start. After comparing, we get what? a1 is equals to 2, a2 is equals to 3, a3 is equals to 2, n1 is equals to 3, n2 is equals to 5 and n3 is equals to 7. Okay, now we have to find capital N, that is the product of n1, n2, n3, that is 3, 5, 7. What we will get? 1, 0, 5. Okay, what we will get? 1, 0, 5. Now we have to find n1 because a1, a2, a3 is already here. Now how we will find a capital N1? It is equals to capital N. N1 is equals to capital N upon a small n1. Capital N1 is what? 105 and a small n1 is 3. After dividing, what we will get? 35. Okay. Now n2. Similarly, we find n2, that is what we will get? 105. 5. What we will get? 21. n3 is equals to n upon n3, 105 upon 7, what we will get? 15. Okay, now we are going to find s1, x2, x3. Let us consider the linear congruence n1 x1 modulo n1, n2 x congruent 1 modulo n2, and n3 x1 modulo n3. So we are considering this linear congruence. We are going to put the value here. What is n1? What we will found? n1 is 35. So 35x congruent 1 modulo n1. n2 is 21. X congruent 1 modulo n2. Sorry, I have also the value of n1. What is small n1? Small n1 is 3. So we can write here 3. Small n2 is what? 5. So here we write 5. And this is 15x modulo 1 modulo 7. Now we are going to find the value of x1, x2, x3 from here. Okay. I hope you know how to solve the linear congruences. Okay. So how to solve this linear congruence? So if you see, if you divide the 35 by 3, you get the remainder 2. So you can write it as 2x1 congruent 1 modulo 3. Okay. So if we put the value of x1 is equals to 2, so we get 2 2s are 4, and if we divide 4 by 3, we get the remainder 1. So x1 is what? 2. So from here again dividing 21 by 5, we get the remainder 1. So x2 congruent modulo mod 5. As you see, x2 is equals to 1. When 5 divide 1, we get the remainder 1 itself. So x2 is 1. Again 7 divided 50, we get the remainder 1. So modulo 7. Now again x3 is 1 for the same reason. Now we can find x bar. Now put the value of this x3. What is a1? That is 2. n1 is 35 and x1 is 2. Likewise we write 3, 21, this is 1. a3 is 2, this is 15, this is 1. Multiply it, 140, 63, this is 30. After addition we get 233. So this will be the simultaneous solution of system of linear congruences modulo what? N is equals to 105. We get capital N is equals to 105. X is equals to 23 be the unique solution. So here I write 23. Why? Because modulo n value is 105 and this is bigger. So we divide 105. So we divide 233 by 105. We get the remainder 23. And this remainder value is the unique solution for the given system of linear congruences. Or you may also choose this way. You write this solution x bar and minus 105. You get the value 128. If subtracting up to you don't get the answer lesser than 105. You get 3. This is 2. So 23. So this is lesser than 105. So this is the unique solution. You choose any way to find the answer. Okay. Let's move to the next question. So this question is homework for you. Do practice and I will provide you the answer. Answer is 785. Okay. The unique value of x is 785. Okay. If you find any difficulty, please comment down below. I make the video for the solution. Okay. Now next question is solve the linear congruences 17x modulo 9 modulo 276. So this is the most asked question for this video. So I am going to solve it using Chinese remainder theorem. Okay. So first of all, to make the linear congruences in the format of Chinese remainder theorem, you have to find the factorization of 276. You find 2 square 3 cross 23. Okay. So you can write 17x modulo 9 mod 4, 17x modulo 9 mod 3 and 17x modulo 9 mod 23. Okay. So for the unique solution, that A, you know that AX congruent B modulo N. So X have the unique solution if GCD of A and N is equals to 1. Okay. So the GCD of 17 and 4, 17 and 3, 17 and 23 is 1. So GCD of 17 and 4, GCD of 17 and 3, GCD of 17 and 23 is equals to 1. So this system of linear congruences is going to have a unique solution. Okay. So let's find out. So give it equation 1, 2, 3. So you already know the format how to write the theory. So I am doing it directly here. 17x modulo 9 mod 4 is going to be reduced like if modulo 1 modulo 4. See, 9 minus 1 is equals to 8 and 4 divides 8, so the remainder is 0. So you can write 17x modulo. In place of 9 you are going to write 1 modulo 4. Okay. Now if you solve 17x, just keep the value x here, modulo 4. So 17x minus x is 16x and 16 is divided by 4 completely. So again you can write x here. This is 1 modulo 4. Okay. So this is the one of the equation. Write it 1 dash. It is in the form of Chinese remainder theorem. Okay. The system of linear congruences. Now for equation 2, this is for 1. For 2, this is 17x congruent 9 mod 3. So 9 congruency 0 mod 3, because 9 minus 0 9 and 3 completely divides 9. So you can write 17x modulo 0 mod 3. Okay. Again you can see, you can write it as 17x. This is 17 product 0 mod 3, and you know one of the property that AC congruent BC mod n and D is equals to GCD of C and N. Then A congruent B mod and divide by D. Okay. So here 17 and 3 is, so the GCD of 17 and 3 is 1. So you can easily write it as x congruent 0 mod 3. Okay. So this is 2 dash. After comparing with the system of linear congruences, so comparing with system of linear congruences, we get A1 is equals to 1, A2 is equals to 0, that is A1, that is A2, and N1, and N1 is equals to 4 and N2 is equals to 3 here. Okay. So we can easily find capital N, that is N1 dot N2, that is 3 4 are 12, so it's 12. Now find capital N1. Okay, capital N will be this much. So this is 12 upon 4, this is 3, and N2 is N upon N2, that is 12 upon 3, that is equals to 4. Now we have to find x1, x2. So this is, so let us consider the system of linear congruence. We get N1 x congruent 1 modulo N1, N2 x congruent 1 modulo N2. N1 is 3x congruent 1 modulo 4, and this is 4x congruent 1 modulo 3. If we put the value of x1 is equals to 3, we get 3 3 is 9, and if we divide 9 by 4, we get the remainder 1 here. So x1 is equals to 3, and similarly we find that x2 is equals to 1. If we put the value 1 and divide 4 by 3, we get the remainder 1. So x2 is equals to 1. Now we find xr, that is a1 n1 x1, that is a2 n2 x2. After putting all the value, this will become 0, because the value of a1 is itself 0, and sorry, the value of a2 is 0. Okay, a2 is 0. I will write it here. So the value of a1 is 1, n2 is 3, and x2 is 3, and this will become 0 because the value of a2 is 0. So this is become 9. So this is the simultaneous solution of system of linear congruence modulo what? Modulo 2s. But you have to find the unique solution for modulo 276, because that is the original question, because that is That is the question. Okay. Now, so we find that x bar is equals to 9. Okay. So modulo 12. So by using linear Diophantine equation, we can write it as x is equals to 12t plus 9. Okay. Put the value in equation 3. Put the value of 4 in equation 3. What is equation 3? What is equation 3? In this linear congruence, we are going to put the value of x, that is 9 plus 12, 3. We get 17. 9 plus 12t congruent 9 modulo 23, that is 204 t plus 153 congruent 9 modulo 23. So you can see 204. Okay, so 204 modulo minus 3 mod 23, and 23 into 9 is 207. So if we add 3 to it, it completely divides it. 23 completely divides that 207. So in place of 204, we can write minus 3t, and modulo 153 come this side. This will become 144 modulo 23. Now how can we solve for 144? So 144 modulo, we know that 23 into 8, 138. If we subtract 6 here, modulo 23, it completely divides. So if we write 6, 144 minus 6 is 138, and it completely divides it. The remainder is 0. So we, in place of 144, we write minus 3t minus 6 modulo 23. Again using the property of linear congruence, that is minus 3 into 2 mod 23. GCD of 3 and 23 is 1. So we can get t congruent 2 modulo 23. We can also write it as equals to 23j plus 2. Put the value of t in equation 4. We get x is equals to 12. 23j plus 2 plus 9. We get x is equals to. So this is 276j. This is 24 plus 9. X is equals to. This is 24 plus 9. 33 plus 276j. You can also write it as x congruent 33 modulo 276. So this is the unique solution. X is equals to 33 is a unique solution for the given linear congruence, that is 17x congruent 9 modulo 26. X is equals to 33 is unique solution. So I hope you understand the whole example. So if you like this video, please hit the like button. Don't forget to subscribe my channel and hit the bell icon for further notification. Thanks for watching this video.